Hello and welcome to another section in further mathematics. In this section we'll be looking at the topic the circle. But before that, let's review our previous lesson. Okay, welcome back. Now today we'll be talking on the topic the circle and its equation. Now when we talk about the circle and its equation, we are talking about the equation that can be used in solving problems that involve a circle, and these equations can actually be generated from the circle on its own. Now let's explain the terms of what we can see in front of us. Now we have it here that a circle is defined as the locus of a point equidistant from a fixed point. Now what is the locus of a point equidistant from a fixed point? Now let's assume that this is a fixed point. This is just a point. You tie in a rope at this point. This is a stick. Let's take it to be a pole. This should be a pole. Yeah, with a rope beside it. Now from this point to this point is a fixed point. Now you could discover that from this point to this point, by the time you keep turning it, you keep producing a point like this. That's how the point keeps going. The point goes this way, go this way until a circle is being produced. So it is a locus, that's a line from this point to here, equidistant from a fixed point. This is the fixed point, and it's equal distance to here, equal distance to here, equal distance to here, equal distance, equal distance. So the distance from this fixed point to this arc is called the point, the locus itself. So now the circle is defined as the locus of a point equidistant from a fixed point. A circle is completely specified by the center and the radius. So this line is called the radius. The radius, you know, a line from this part of the circle to this other part is called the diameter, and half of the diameter, so from the midpoint to any point, it's called the radius of a circle. So the radius is from the fixed point to any point in the arc, so that is the radius. And the radius, equation of a circle with center A and B. Now this is the point, the center. The A signifies the point in the x-axis, and the B signifies the point in the x-axis. Now let me tell you how points are usually denoted when it comes to circle and point. Now this is the y-axis, this is the x-axis, this is x-axis, this is the y-axis. Now let's assume that this is 4 and this is 2. If you take this point and take this point is known as 3 and 4. So it's to tell you that in our x-axis this point is equal to 3, and in the y-axis this point is 4. So the distance from this point to here is 3, and the distance from here to here is 4. So we are talking about the distance from the x-axis to the center of the circle symbolizes A, while the distance from the y-axis to the middle of the circle symbolizes B. And when you want to calculate the equation of a circle, this is the generally accepted equation, and we have r squared. Remember we said r is the radius, A is the distance from the x-axis to this point, so that's why you use the symbol x minus A, and this point is the distance from the y-axis to point B. So if you create it like this, you discover that you form a Pythagoras theorem with the radius being the point from the midpoint to here. So that's why it is being stated as r squared equals, now here to here symbolizes the point. This is point x, this is point A. So this point is x minus A, while this point is y minus B. So if this is x minus A and this is y minus B, we now have an equation, we now have a right angle triangle. Okay, let me make this other side, make a sketch of it so that we'll understand what we are trying to talk about. So with that, we now have a situation of a right angle triangle. And in that right angle triangle, we'll apply the Pythagoras theorem. Now the right angle triangle is of the form, okay, we have it, and this is point R, which symbolizes the radius. And remember here, this is point X and this is A, so the distance between X and A, which serves as the base, is X minus A. So these are X minus A, and this point Y to B is called let me take this off, is called Y minus B. So this is the Y axis and this is the X axis. So according to Pythagoras theorem, this is a right angle triangle. This is just a proof of how the equation of a circle is being gotten. So according to Pythagoras theorem, remember that the square of the hypotenuse, where we applied the SOHCAHTOA, which is sine, that says opposite of a hypotenuse, cos adjacent of a hypotenuse, and tan opposite of a adjacent. So here it's trying to tell us that the square of the hypotenuse, which is r squared, is equivalent to the square of this plus this. So it's equivalent to the square of x minus a all square plus y minus b all square. So this is where we got our equation of a circle from. It was gotten from the Pythagoras theorem. Now, if the center of the circle is the origin, now if the center of the circle happens to be the origin, the equation becomes this form. Now, you know, if the center becomes the origin, the value of a and b becomes 0. So we now have r squared equals x minus 0 is x squared plus y minus 0 is y squared. So we now have r squared equals x squared plus y squared. Now from this equation, we have this r squared. If you expand this using the, I want us to make use of the Pascal's triangle. We did that in our previous lesson. Pascal, this is 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1 continuously. I know you understand the Pascal's triangle. So with this, we want to expand x minus a squared is in this range. That's the second group. We have x, a, and a. So this is square, this is square. We have minus, then 2ax. Then here this point becomes plus this. But we have 1, 2, 1. So this is 1, 2, 1. So these are value for x minus a squared using the Pascal's triangle. And that's why we have x squared. So we now have x squared minus 2ax plus a squared. So this happens to be this is x squared minus 2ax, just like what we have here, plus a squared. And you do same to y, you'll be having y squared minus 2yb plus b squared, just here. And we have y squared minus 2yb plus b squared. Then r squared, you bring it inside, it becomes minus r squared. And by the time you do it this way, at this point, we now have this proof to be the equation. Then the above equation can be written as this. Now this can only be gotten because since the value of our a is minus, so minus a is equal to g. That's why I have 2gx in this point, and minus b is being represented with f. So we now have 2fy with this plus c equals 0. Hence, this is the final equation, and it's called the general equation of a circle. Observe the following about the general equation. It is a second degree equation in x and y. That is to tell you that the highest power of unknown is 2. That's the meaning of this. So you can't see anything like equation of a circle. You start seeing x3 plus y3. This is never an equation of a circle. Equation of a circle, the maximum is second degree, x squared, y squared, and so on. Secondly, this is the second point of x and y. Secondly, the coefficient of x and y are equal. You can't see an equation of a circle with 2xy plus y squared. No. whatever is attached to x must be attached to y squared. Whatever is attached to x squared must be attached to y squared. And it has no xy term. So it's only x squared plus y squared plus 2gx. There's no term like 2xy or 4xy in equation of a circle. I want you to note all these points whenever you're dealing with equations of a circle. Now, when we meet in our next class, we'll continue solving questions that has to do with this. I would like to say a very big thank you for joining us in this lesson session. Now, in order for you to refresh your memory and get intact what we just discussed, please take the text that will appear on the screen shortly. Do well to always use the lesson notes on this platform for a better information on the topic we've discussed. Thank you. See you in our next lesson.